You ever walk into your kitchen, absolutely sure you needed something, only to just stand there, completely blank?
Oh, yeah. Or you meet someone new, hear their name, and like 2 seconds later, poof, gone.
Exactly. It's those little memory glitches, right? We've all been there. And that's actually what we're diving into today.
Right. The whole fascinating, sometimes really frustrating world of how our memory works and why it sometimes doesn't.
For this deep dive, we've gathered quite a mix of stuff.
Yeah, we've got psychology textbooks, some research papers, even transcripts from science videos. It gives a pretty wide view.
Yeah, a comprehensive look at memory, how it's built, how it fails, and honestly, how easily it can sometimes be tricked.
Our goal here really is to pull out the key ideas, the strength, the weaknesses, and those moments that make you go, aha, about how memory shapes, well, everything.
Okay, so memory. It feels huge. Where do we even start trying to unpack it all?
Well, a good place to begin is thinking about memory as a process, like a journey with different steps. Yeah, psychologists usually talk about 3 main stages. First, there's encoding. That's basically the learning part, getting the information in.
Okay, encoding. Got it.
Then there's storage, which is, keeping that information hanging around over time.
Right, holding on to it.
And finally, retrieval. That's the accessing part, pulling it back out when you need it.
So is it kind of like taking a picture, saving it to your phone, and then finding it in your gallery later?
That's a helpful way to think about it, definitely. But it's important to remember our actual biological memory is way more complex, more dynamic.
Right, not quite a perfect digital copy.
Exactly. And failures, whether it's forgetting where you parked or like having a totally false memory, those can happen at any of those points.
Yeah.
Encoding, storage, or retrieval.
Ah, I see. So it's not always about losing it. It could be you never stored it right, or you just can't find it later.
Precisely. Which really affects how we learn new stuff, too. And we should probably mention the different types of memory the sources talk about.
Oh, yeah. Like what?
Well, there's working memory, the stuff you're juggling in your head right now. Then episodic memory for your personal experiences, like your last birthday.
Okay.
And semantic memory, which is more for general facts, like knowing Paris is the capital of France.
Right, right. So not just one big filing cabinet in the brain. That makes sense. Now, one thing I think a lot of us just assume is that memory is like a perfect recording.
Yeah, like a video camera capturing everything exactly.
But the sources really push back on that idea, don't they?
Absolutely. A really key concept is that remembering is reconstructive. It's not like just hitting play.
Reconstructive.
So when you recall something, your brain is actually piecing together fragments of information. And crucially, that reconstruction process, it's influenced by what you believe now, your expectations, even stuff you learned after the event happened.
Wow. So those memory traces, the physical changes in the brain people talk about, they're not like complete files.
Exactly. Think of them more like clues or maybe building blocks. Scientists call them engrams, these physical changes. But yeah, definitely not perfect copies.
Huh. That really explains why memory can be so unreliable sometimes, if we're rebuilding it each time.
It makes you question things, doesn't it? Even really vivid memories might not be exactly how things happened.
Which brings us neatly to forgetting, something we all do. The sources talk about normal, everyday forgetting versus more serious stuff. What's the difference there?
Well, everyday forgetting, like, where did I put my keys this time? That can increase a bit as we get older. Totally normal. Maybe takes a bit longer to learn something new.
Okay. Annoying, but normal.
Right. It doesn't usually mess up your daily life. But significant memory loss, that can be different. It might be a sign of an underlying medical issue or disease.
And the word amnesia comes up a lot. What exactly does that cover?
Amnesia basically means a pretty major loss of long-term memory. It can happen because of disease or a physical injury like a bad concussion, or even sometimes severe psychological trauma. And our sources highlight 2 main types: anterograde and retrograde. Seeing the difference really shows how memory isn't just one single thing in the brain.
All right, let's break those down. Anterograde. Does that mean like forward in time?
Exactly. Anterograde amnesia is when someone can't form new memories after whatever caused the amnesia.
So they remember the past, but can't make new memories.
Pretty much. They might remember everything from before their injury, but struggle to learn anything new. The hippocampus, a brain area vital for making new memories stick, is often involved.
Ah, the hippocampus.
Yeah. The classic case is patient HM. After surgery, he couldn't form new memories of events or facts. That's episodic and semantic memory.
Right.
But He could still learn new skills, like getting better at a puzzle task each time, even though he had zero conscious memory of ever doing the puzzle before.
Whoa, so he learned the skill without remembering the learning.
Isn't that wild? It shows different memory systems at work. Some unconscious learning can still happen.
Fascinating. Okay, so if that's anterograde, what's retrograde? The opposite.
You got it. Retrograde amnesia is losing memories from before the event happened.
Ah, losing the past.
Yeah, and how much is lost can really vary. Could be just the moments before an accident, or in some really severe cases, like the former NFL player Scott Balzan mentioned in the sources, it could be decades of life.
Losing 46 years of memory. I can't even imagine that.
It really makes you think about how much our identity is tied to our past experiences. What happens when that's just gone?
Yeah. And the sources also link memory issues to other things, like mental health.
Definitely. Things like severe stress, bipolar disorder, depression, even schizophrenia can sometimes involve cognitive difficulties, including memory problems. And then, of course, there are different forms of dementia, like Alzheimer's or vascular dementia, where progressive memory decline is a core symptom.
Right.
And on a more common level, there's forgetting caused by interference, specifically retroactive interference.
Retroactive. Sounds like something going backwards.
Yeah. Kinda. It's when learning something new makes it harder to remember something old. Like, study French, then Spanish, and suddenly you're mixing up French words because the Spanish is interfering.
Ah, I've totally done that. Okay, so that's forgetting, sort of,
Yeah.
from the inside. But what about external stuff? The sources talk a lot about suggestion and misinformation messing with our memories.
Yes, and this is hugely important, especially when you think about things like eyewitnesses. Suggestibility is basically how outside information can actually lead us to form false memories.
False memories, like things that didn't happen.
Exactly. The DC Sniper Tips hotline example they give is interesting. So many calls, so many different descriptions. That sheer volume of suggestion could unintentionally shape what genuine witnesses thought they remembered.
So our memories can get contaminated, almost.
That's a really good way to put it. Psychologist Elizabeth Loftus did groundbreaking work on this. She developed the misinformation effect paradigm.
Okay, what's that?
Her studies basically showed, again and again, that if you expose people to incorrect information after they witness something, it can actually change their memory of the original event.
How so?
The classic study involved showing people a scene with, say, a stop sign. Later, if the question subtly mentioned a yield sign instead, many participants would incorrectly remember seeing a yield sign.
Wow. Just the wording of a question.
Even subtle phrasing, yeah. It shows just how malleable memory can be.
And the sources say some groups are more prone to this, like kids and older adults.
That's right. Younger adults too, actually. Different groups seem to be vulnerable in slightly different ways. And it doesn't have to be deliberate deception. Even just unintentional cues can warp a memory.
Which has massive implications for eyewitness testimony in court, right?
Absolutely massive. This is where it gets really critical. We see eyewitnesses in crime shows all the time pointing someone out.
Yeah, the dramatic courtroom moment.
But our sources paint a much more, well, concerning picture. The Innocence Project's work is sobering.
What'd they find?
Eyewitness misidentification is one of the leading causes of wrongful convictions they've uncovered. People sent to prison for crimes they didn't commit because an eyewitness got it wrong.
That's terrifying.
The case of Jennifer Thompson and Ronald Cotton is a powerful example. She was absolutely certain he was the attacker, completely sure.
But he wasn't.
He wasn't. He spent years in prison before DNA evidence exonerated him, and sadly, sometimes suggestive police questioning, even if well-intentioned, can make a witness more certain of an incorrect identification.
Oh, man. But then the Elizabeth Smart case is mentioned as a contrast.
Right, that's a really important counterpoint. The police were apparently very careful with her younger sister, Mary Catherine, who was the only witness to the abduction initially.
How so?
They deliberately avoided leading questions, didn't use suggestive techniques. They tried to preserve the integrity of her memory, and months later, her recollection proved crucial in identifying the kidnapper.
So how investigators handle witnesses makes a huge difference.
A critical difference. And it's not just questioning. The sources also mention other factors.
Like what?
Like, how good was the lighting when the crime happened? Was the witness under extreme stress? How much time passed between the event and the identification? All these things impact accuracy.
Makes sense. It's not like watching a movie.
Not at all. And that's why there are recommendations now for improving police lineups.
Oh, yeah. Like what kind of things?
Things like making sure everyone in the lineup matches the initial description, a fair lineup. using a blind administrator, someone who doesn't know who the actual suspect is so they can't accidentally give cues.
Oh, that's smart.
Giving unbiased instructions, making it clear the actual perpetrator might not be in the lineup, and using sequential lineups.
Sequential, you mean showing them one person at a time?
Exactly, instead of showing everyone at once. The idea is it encourages the witness to compare each person to their actual memory, rather than just picking the person who looks most like the perpetrator compared to the others in the group.
That makes a lot of sense. Less pressure to just pick someone. And the idea of totally implanted false memories, like remembering being lost in a mall when it never happened, is that really possible?
Research shows it is. It sounds wild, but studies have successfully implanted memories for things that definitely didn't occur.
Like what?
Like vividly remembering meeting Bugs Bunny at Disneyland.
Bugs Bunny isn't a Disney character.
Exactly. Impossible event. Or recalling a hot air balloon ride based on seeing a photoshopped picture of themselves in one.
Seriously. And people believe these fake memories.
Often, yes. And what's really striking is how hard it can be for the person to tell the difference between a real memory and one that's been implanted. They can feel equally real.
Wow.
There's also the strange case of Donald Thompson, who was wrongly accused of rape because the victim had seen him being interviewed on TV shortly before the attack. Her memory misattributed the source. She recognized his face, but associated it with the wrong event.
Okay, mind blown a little bit. So memories can fail, they can be tricked. Now, let's switch gears slightly. The sources also talk about learning classical and operant conditioning. How does that fit in?
Ah, yes. These are absolutely fundamental to how we form certain kinds of memories, especially about associations and consequences.
Okay, classical conditioning. That's Pavlov's dogs, right? The bell and the drooling.
That's the classic example. It's learning through association. A neutral stimulus, like the bell, gets paired repeatedly with something that naturally causes a response, like food causing salivation.
The unconditioned stimulus and response.
Right. Food is the unconditioned stimulus, US. Salivation is the unconditioned response. After enough pairings, the bell, which started neutral, becomes a conditioned stimulus, CS.
And it makes the dogs drool just by itself.
Exactly. The bell alone triggers salivation, which is now the conditioned response, CR. It's like the brain learns to predict. Bell means food is coming.
So the guinea pig example in one video, getting excited by the fridge door, sound before the carrot appeared. That's it.
Perfect example. The door sound, CS, predicts the carrot, US, leading to excitement, CR. And we see this all the time. Your alarm clock sound might become a CS for feeling grumpy.
Oh, definitely.
Or seeing a familiar fast food logo might make you feel a little hungry. That's learned association.
And the little Albert experiment, that was conditioning fear.
Yes, sadly. Watson conditioned a baby to fear a white rat by pairing it with a loud noise. Highly unethical, of course, but it showed emotional responses could be conditioned.
Yeah, definitely couldn't do that today.
The sources also touch on things like blocking, where an existing association can prevent a new one forming, and preparedness, our biological tendency to link certain things easily, like taste and feeling sick.
Okay, and then there's extinction.
Yeah.
Where the learned response fades.
Right. If you keep bringing the bell, CS, but start bringing the food, US, the dog's conditioned salivation, CR, will gradually weaken and disappear. Though sometimes it can pop back up later, that's spontaneous recovery.
Okay, so that's classical conditioning. What about operant conditioning?
Operant conditioning, associated strongly with B.F. Skinner, is about learning through consequences. We learn to associate our voluntary actions with the outcomes they produce.
So behavior that gets rewarded is repeated.
Basically, yes. Behaviors followed by reinforcement, good outcomes tend to increase. Behaviors followed by punishment, bad outcomes tend to decrease. Think of training a dog with treats.
Right. So classical is more automatic associations. Operant is more about choices and consequences.
That's a good way to distinguish them. Classical involves involuntary responses triggered by stimuli. Operant involves voluntary behaviors shaped by their results.
And there's different kinds of reinforcement.
Yep. Positive reinforcement is adding something good, like praise or a treat. Negative reinforcement is removing something bad, like stopping an annoying noise when a lever is pressed. Both increase the likelihood of the behavior.
Okay. And you can shape behavior gradually.
Exactly. Rewarding successive approximations steps closer and closer to the desired action. The sources also mention reinforcement schedules like getting rewarded every time versus only sometimes, which really affects how persistent a behavior is.
Like gambling on a slot machine variable ratio schedule. Very hard to extinguish.
Precisely. And interestingly, the reinforcer devaluation effect shows we learn more than just do this, get that. We also learn the value of the reward. If the reward suddenly becomes undesirable, the behavior often decreases.
So it's not just robotic stimulus response.
No, there's an understanding of the goal involved, which ties into the difference between goal-directed actions and ingrained habits. And sometimes classical cues can actually motivate operant behavior.
How does that work?
Like for someone with addiction, seeing drug paraphernalia, a CS, can trigger craving, CR, and strongly motivate the operant behavior of seeking out drugs. The two systems interact.
Wow, okay, it's all really interconnected. So bringing this back to memory encoding, storage, retrieval, how does this learning stuff connect?
Well, effective encoding getting memories in solidly often relies on these principles. Relating new info to what you already know, forming mental images, making associations. That's all about linking stimuli and creating meaningful connections.
So good learning strategies are basically good encoding strategies.
Pretty much. And the encoding specificity principle is key here. It says retrieval works best when the cues available when you try to remember match the cues that were present when you first learned it.
Ah, so that's why going back to the place where something happened can trigger memories?
Yeah.
The context acts as a retrieval cue.
Exactly. The environment matches the encoding context. And sometimes recall, pulling info out of your head, can actually be better than recognition, seeing something and knowing you've seen it before, if the recall cues are stronger or more specific.
Interesting.
And the act of retrieval itself changes memory. The testing effect shows that practicing retrieval, like quizzing yourself, actually strengthens the memory more than just rereading.
So testing isn't just assessment, it's learning.
It's a powerful learning tool. But retrieval isn't always good. There's also retrieval-induced forgetting. Remembering one thing can actually make you forget related things.
Huh. Like pulling out one file makes others harder to find.
Sort of, yeah. And again, retrieving older memories is that reconstructive process we talked about, prone to errors.
And what about the biology, the brain stuff?
The sources touch on that too. Long-term memory seems to involve physical changes at the connections between neurons. It's called synaptic plasticity.
Strengthening connections?
Right. The NMDA receptor is important here, and that phrase, cells that fire together, wire together, captures the idea that neurons active at the same time strengthen their link.
Okay.
And specific brain areas are key. We mentioned the hippocampus for new long-term memories. Think place cells in RATS mapping environments or patient HM's deficits. The cerebellum seems crucial for procedural memory, like learning coordinated movements or conditioned responses like an eye blink.
And emotions.
The amygdala is heavily involved in emotional learning and memory associating stimuli with fear or reward, like learning to sweat when seeing a colored square previously paired with a shock.
Got it. And mnemonics, those memory tricks.
Yeah, things like the peg word system or memory palaces like Simon Reinhard uses for those incredible memory feats. They're basically clever ways to leverage these principles, association, imagery structure, to deliberately boost encoding and retrieval.
So wrapping this all up, memory is, well, it's incredibly complex.
Definitely. Multi-layered, fundamental to everything we do.
And it's not a perfect recorder. It's fallible, it's reconstructive.
Yeah, shaped by internal stuff, external stuff, suggestion.
In those basic learning principles, classical and operant conditioning, they're woven right into how memories form and how we get them back out.
Exactly. Which I think leads to a really big question for you, the listener, to think about.
Which is?
Given that memory is reconstructive, and we know it can be influenced by suggestion and misinformation, how much can we really truly trust our own memories or the memories of others?
Oof. That's a heavy one. It really makes you reconsider things. From studying for an exam to, well, how the justice system works.
Absolutely. There's so much more to explore here. You could look into those cases we mentioned, Ronald Cotton, HM, Little Albert.
Or check out some memory improvement techniques. Maybe try building a memory palace.
Why not? The science of memory is always uncovering more about this core part of being human. It's a fascinating journey.